All right, let's dive in. Today, we're decoding the decoders. We're going to go straight to the very core of AI to really get a handle on the fundamental architectures that power the large language models you and I use every day.
You've heard the names thrown around all the time, right? GPT, T5, ChatGLM. And on the surface, they all kind of seem to do the same thing. But under the hood, they're actually built on fundamentally different principles. So, what really is the difference?
Well, it all boils down to one single, really elegant concept. It's all about how they see information. The whole secret is in what we call their attention mechanism, which is just a fancy way of saying it's the specific way each model reads, processes, and pays attention to the data we feed it.
Okay, so here's our game plan for today. We'll start with AI's three core brains. Then we'll meet each one: the translator, the storyteller, and the hybrid. After that, we'll compare them side by side and wrap up with why any of this actually matters.
First up, AI's three core brains. And honestly, the best way to think about this is like a family tree. We're basically tracing the evolution of these different architectures.
So, let's meet the first member of the family, the one that started it all, the translator. This is the classic encoder-decoder architecture.
So meet the translator. Just imagine a professional human translator. They're not going to start talking until they've heard or read the entire sentence, right? They need that full context first. That's exactly how this architecture works. It reads everything before it writes anything.
So how does it actually work? Well, it's a two-step dance. First, you have the encoder. It reads the entire input using something called bidirectional attention. That just means it's not just reading left to right, it's looking at every word and how it relates to every other word, forwards and backwards, to get this really deep, complete picture. And only after it's done all that does the decoder kick in and start generating the output. And the whole time, it's constantly looking back at that complete picture the encoder built.
And because it's so meticulous, this makes it absolutely perfect for tasks like translation or summarization, things where you have to understand the full context. The key feature here is something called cross-attention. Think of it like a communication bridge that lets the decoder constantly check back with what the encoder understood, and you'll see this in popular models like T5 and BART.
All right, let's move on to the next branch of the family tree, the storyteller. This is the causal decoder architecture, and I'm willing to bet this is the one you've probably played with the most.
Okay, so let's meet the storyteller. I want you to think of this one like a word chain master. It has one and only one very strict rule. It can only ever look at the words that have already been written. It's always moving forward, one word at a time, never, ever peeking ahead.
And what's so fascinating about this is that the model treats your prompt and its own answer as the exact same thing, just one long continuous stream of words. So when it's trying to predict the very next word, it just looks back at everything that came before it, no matter if you wrote it or it did.
This strictly forward-looking approach is exactly why it's so good at things like open-ended generation and chatbots. Its defining feature is that causal attention. And yeah, this is the architecture behind the absolute heavyweights of the AI world, the GPT series, Llama, and Palm.
Okay, so our third and final architecture is a really clever mix of the first two. Meet the hybrid, also known as the prefix decoder. And it really does try to combine the best of both worlds.
So let's meet the hybrid. The best analogy here is to think of a really good student getting an essay question. What do? First, they read that question over and over from all angles, making sure they understand exactly what's being asked. And only then, once they've got it, do they pick up the pen and start writing. So let's break that down. In phase one, it's all about your prompt, what we call the prefix. And in this phase, it acts just like an encoder. It uses that bidirectional attention to look at your prompt from every possible angle, really digging in to get a deep, complete understanding of what you're asking.
Then, and this is the cool part, once it's totally sure it understands the prompt, it completely switches modes. It starts writing the answer just like a causal decoder, one word at a time, only looking back at the prompt and the words it's already generated.
And this two-step process is what makes it so incredibly powerful for things like advanced prompting or in-context learning, because it gets such a rich understanding of your instructions right from the start. Its key feature is this hybrid masking, and a great example is the GLM series, which you might know from ChatGLM. Okay, so we've met the whole family. Now let's put them all side by side and really highlight what makes them different.
Before we get to the full comparison, let's zoom in on the single most important difference here: how they process the input.
It's basically a showdown between the full context, bidirectional attention of the translator and the hybrid versus the strictly forward-looking attention of the storyteller. Honestly, this one difference changes everything.
Okay, here it is, the full picture. Let's just walk through this together. If you look at the structure, you can see the clear difference between the two-part encoder-decoder and the single-part, decoder-only models. Then, for input attention, you see how the encoder and prefix models share that bidirectional approach, while the causal model is all on its own with its unidirectional method. When we get to output attention, the really big deal is that cross-attention that only the encoder-decoder uses to look back at the original input. And then down at the bottom, you can see which famous models fall into each category.
So, I know we've covered a lot of pretty technical stuff, but what's the big takeaway here? Let's boil it all down to what you really need to remember.
Look, if you remember just one thing from all of this, let it be these three core ideas. The encoder-decoder, that's two brains connected by a bridge. The causal decoder, that's one brain that only ever looks forward. And the prefix decoder, that's one brain that reads the prompt thoroughly first and then starts writing. Simple as that. And there you have it. Those are the three core architectures that really define modern AI. In the end, it all comes down to how they pay attention. So now that you understand the what, are you ready to go one level deeper? Because the next big question we have to ask is, how does that supercritical piece, cross-attention, actually work?